Hello everyone, and welcome to Solution Nuggets. In today's video, we're diving into an essential concept in mathematics, linear equations. Within the topic of linear equations, we will begin by exploring the gradient as a substrand. The gradient is a fundamental concept for understanding lines and relationships in both algebra and geometry, and it's a key idea that appears repeatedly across various fields of study. Here's what we'll be covering in this video. 1. The basics. We'll start by explaining what the gradient or slope of a line really means and how to visualize it. 2. Defining the gradient, m, understanding the role of m, gradient, in the linear equation. 3. Finding the gradient and equation of a line. We'll walk through how to determine the gradient and write an equation for a line when we're given either 2 points or 1 point along with the gradient. 4. The general form of linear equations. 5. Plotting linear graphs. We'll plot a few lines together to show how different gradients create different slopes on a graph. 6. Gradients of perpendicular and parallel lines. 7. Using graphs to solve simultaneous equations. Whether you're brushing up on math skills, preparing for exams, or just curious about the topic, you're in the right place. So grab your notebook, get comfortable, and let's unlock the secrets of the gradient. Gradient. Gradient, m, is a unitless parameter used to measure the steepness of a slope. Consider these triangles. Gentle slope. Steep slope. Very steep slopes. You may notice that the triangles do not provide conclusive information about the slope. But the question is, how steep is a steep slope? And how gentle is a gentle slope? To answer this question, we need to quantify the steepness of the slope using numbers. Therefore, quantitatively, gradient is the ratio of the distance moved in the y direction, as you can see on the Cartesian plane to the side, relative to the distance moved in the x direction as indicated by use of the arrow. The values used to quantify the steepness of a slope range from 0 to infinity. Here, infinity means limitless. A horizontal line has a gradient of 0, while a vertical line has an undefined gradient or infinite. How to work out gradient given 2 points. Draw line AB, with coordinates A and B named x1, y1, and x2, y2 respectively. Consider moving from point A to point B along the line. We can define the gradient as shown by the blue triangle, as the distance moved in the y direction as shown by the arrows, divided by the distance moved in the x direction indicated by the arrow. By definition, gradient denoted by letter m is given by y2 minus y1 over x2 minus x1. Note better, you must be consistent. If you start with point A when finding change in y, you must also start with point A when finding change in x. In conclusion, the formula for calculating the gradient is given by the change in y over the change in x. In this context, the word change is represented by the Greek letter delta, as shown. Types of gradients. In this demonstration, I'm going to show you the different types of gradients using a Cartesian plane. Follow along closely to learn the differences. Zero gradient, represented by a horizontal line, indicating no slope or the change in y is 0 while change in x is positive. Positive gradient, where the slope rises as it moves from left to right. Both x and y values increasing. Negative gradient, the slope falls as it moves from left to right, where the change in y is negative and the change in x is positive, or vice versa. As x increases, y decreases. Undefined gradient, represented by a vertical line, the gradient is considered infinite or undefined because it involves the division of a number by zero. Division of a number by zero gives infinite results. The gradient of a line. To calculate the gradient between 2 points, we use the formula above. I will start by drawing a line L2 with two coordinates, A and B. Each coordinate has two values, x and y. The first number in each coordinate represents the x value, while the second number represents the y value. To calculate the gradient, I'll begin by finding the change in y. In our example, the change in y is given by 7 minus 3, starting from point B. This means we calculate point B minus point A. The change in x is given by 4 minus 2, also starting from point B. As mentioned, if you start with B for y, you must start with B for x as well. Therefore, the gradient is calculated as follows. The change in y, 7 minus 3, is 4. The change in x, 4 minus 2, is 2. Dividing 4 by 2 gives us 2. We can conclude that the gradient between the 2 points along line L2 is 2. I hope you got it. If not, let me show you another example using a negative gradient. I will start by drawing a line L3 with two coordinates, A and B. To calculate the gradient, I'll begin by finding the change in y. In our example 2, the change in y is given by 8 minus 2, starting from point B. This means we calculate point B minus point A. The change in x is given by negative 4 minus 1.5, also starting from point B. As earlier emphasized, if you start with B for y, you must start with B for x as well. Therefore, the gradient is calculated as follows. The change in y, 8 minus 2, is 6. The change in x, negative 4 minus 1.5, is negative 5.5. Dividing 6 by negative 5.5 gives us negative 1.09. This is because a positive number divided by a negative number will result in a negative number. The gradient between the 2 points along line L3 is therefore negative 1.09. Example 3 with 0 gradient. Draw a line L3 with two coordinates, A and B. Find the change in y. The change in y is given by 6 minus 6, starting from point A. This means we calculate point A minus point B. The change in x is given by negative 4 minus 1.5, also starting from point A. In this case, there is no vertical displacement as you move from point A to point B because a horizontal line has no slope. As earlier mentioned, if you start with A for y, you must start with A for x as well. Therefore, the gradient is calculated as follows. The change in y, 6 minus 6, is 0. The change in x, negative 2 minus 6, is negative 8. Dividing 0 by negative 8 gives us 0, because 0 is divisible by all numbers but cannot divide any number. The gradient between the 2 points along line L3 is therefore 0. Try dividing 0 by any number using your scientific calculator. you will either get an infinite answer or a syntax error, leading to the conclusion that vertical lines have an infinite gradient. Now that you have learned how to calculate the gradient between points, feel free to attempt the given questions below. For each of the following pairs of points, find the change in the y-coordinate and the corresponding change in the x-coordinate. Hence, find the gradients of the lines passing through them. Point K, 5-2, point L, 6, 2. Point M, 6, 3, point N, -6, 2. Thanks for watching. If you enjoyed this video, please subscribe for more Solution Nuggets content. Stay